In this video we'll cover something called parallel circuit with two resistors. So this is the circuit in red, and this is R1, this is R1, which is equal to 20, and this is R2, which is equal to 40. From parallel feature that we noticed before, that any two components that they are parallel to each other, they have the same voltage. Okay, so VR1 equal to VR2, but how we can make sure that VR1 and VR2 are parallel? If you go to R1 is this component, and it's got one point here, another terminal point here, and they are also shared with R2. So VR1 equal to VR2, and because they are parallel to each other. The same two terminal is shared with E2, 20 volt, and this point, the upper terminal, and this point to the lower terminal. We should keep in mind, any teacher will ask you about current in parallel. They will not ask about the voltage. Usually voltage is a part of something else, because they know the feature between two parallel component is they have the same voltage. So why they ask about the voltage? They ask about the current. In this case, they will ask you, what is the current for I total, I1, I2? This is the first question. Okay, so let's see in the diagram what is I total, I1, I2. They are the same. This is diagram and this diagram are the same. The red, I mean in the red. And because they are R1 and R2 sharing the 2 points, we can make it here and here. So the black points, the upper black point is this point, the lower black point is this one, and we have circuits here. Like, see, this is the first circuit, this is the second circuit, so it's obviously parallel. So I total, it's the current going through here or produced here, then it's go like this, and then separate in two currents, I1 and I2, until they become again one current. So I1 here came from up, I2 from this side, and then they come again I total. Okay, so now we know where is I total, I1, I2. So now we want to find the value of I total. I total will equal E divided by R total. And why they are R total? Because they are parallel, and this is the first way to use it to find I total. Okay, so before solving this, we need to find what is R total, and this is the purpose of having this topic. R total, when you have two parallel resistance, we will use this law, which is R total equal R1 multiplied by R2 divided by R1 plus R2. So our R1 is 20, our R2 is 40. So now 20 multiplied by 40 divided by 20 plus 40, which is 800 divided by 60, which is equal to 13.33 ohm. Now we will use this number again to and plug it in this equation. So E, it is the source here, which is voltage, in voltage, 20 divided by 13.33, it will equal 1.45. Okay, ampere. What is this? This is I total. This is the current from this point going through this point. So it's not this point or this line and this line or that line, sorry. It's only this current. Okay, So now we want to find I total I1 in a different way. We can use in this case the parallel feature, which is E20 equal VR1 equal VR2. So I1, the current from this point to this point, or the current from this point to this point, will equal the voltage here divided the resistance here. So what's the voltage here? And we notice that VR1 is parallel to E, which is 20. So VR1 equal 20. So it's not in ohm, it's in voltage. So we'll take 20 voltage for VR1 and divided by 20 ohm here. And so this value is 1 ampere, of course. I didn't put this one here. So I1 is 1 ampere. For I2 is the current from this point that going through this R2 and become here again part of, it's equal to this current going through these 2 points. This one and this one is the same, sorry. So I2 equal VR2, and because the R2 has a 2-point common with E, so it is 20 divided by the R2, which is 40, equal half. And from the previous question we find it 1.5, and here it's I1 and I2 is 1 and 0.5. If we use the KCL law, which is this one, I total equal I1 plus I2. So I1 plus I2, which is this one plus this one, it will equal this one, and now the answer is cancelled. Thank you for watching. Press OK if you like the videos.